Figure 1.11 shows the electric field lines around 3-point charges A, B and C. So these are the 3-point charges A, B and C. Now from the information of this given figure here, the field lines has been associated with these charges, and from the information of these field lines associated with these point charges, we have to answer these three questions A, B and C. So in part A, he is asking which charges are positive. Now from the knowledge of field lines, we know that field lines starts from positive charge and end at negative charge. So the field lines must be coming out of the positive charge. So from this concept, we can say that this charge C is positively charged and this B is negatively charged, and similarly this A is positively charged. So we can say that A is positive, B is negative and C is positive. Now in part B, he is asking which charge has the largest magnitude and why. Now you know this formula in the Gauss law, that phi is equal to Q by epsilon naught, and from here you can say that the amount of flux or the number of field lines that can be associated with the charge is directly proportional to the magnitude of the charge. Clear? So if we take some surfaces corresponding to the given point charges, so if I draw the corresponding surfaces in order to calculate the situation, so you can see that the number of field lines associated with charge C are maximum, so the magnitude of the charge C is maximum. So the answer to this second part B is C. So charge C has the maximum magnitude. Now in part C, he is asking in which region or regions of the picture could the electric field be zero. Justify your answer. So you have to tell whether the neutral point, and the possible choices are near A, near B, near C or nowhere. So this part is again based on the concept of neutral points, like earlier problem 1.23 where we have discussed the concept of neutral points. So there I have told you that neutral points can't exist between unlike charges, so there cannot be any neutral point between A and B, and there cannot be any neutral point between B and C. So the only possibility left is that the neutral point can exist between charges A and C. Clear? And I have told you earlier that the neutral point will always lie near the charge with the smaller magnitude. So if you observe carefully, then you can see that the number of field lines associated with this charge A are less than that of C, so the neutral point must be near to this charge A. So from this information we can say that this option first is right.